today's video, I'll be taking you through all of circle geometry, which includes the main definitions of a circle and all of the circle theorems. Having said all of that, let's get into the main definitions. So here is a list of all the definitions we need to learn. Let's start off with the center, which is obviously the middle part of the circle, which is this point right here. Next in line is the circumference, which is basically a fancy word for the perimeter of a circle, so the circle itself. Next is the chord, and this is a straight line inside the circle that touches 2 points on the circumference, so this line right here. Now these next two definitions depend on the chord. Hopefully you notice that this chord splits the circle into a smaller part here and a larger part right here. The smaller part is always going to be the minor segment, and the larger part is always going to be the major segment. Now we're going to look at a special case of a chord, which is a diameter. Remember, a chord touches 2 points on the circumference of the circle, so any straight line like this, but a diameter has to pass through the center of the circle, so something like this. And the reason why a diameter is special is because it splits a circle into two semicircles. And now, a very important part of the circle is a radius. A radius is just a straight line that starts from the center of a circle and touches the circumference like this. One thing to keep in mind is that a radius is always equal no matter where you are in the circle. So if we had a radius like this would be the same length as this. And if we had another one like this, it would all be the same length. And the final definition is a tangent line, which is any line that touches the circle at one point. So for example, if I drew a line like this, which touches the circle at 2 points, which is this point and this point, that would not be a tangent line. I would have to change it so that it touches it at 1 point, which would be here. So I've defined everything you need to know about a circle, so let's finally move on to the circle theorems. So the first circle theorem states that a tangent and a radius meet at 90 degrees. So if I draw a tangent line, remembering that a tangent touches a circle at a single point, so just right there. And if the radius is going to meet the tangent, then they both need to touch the same point on the circumference, which is going to be right there. And all this circle theorem states is that both of those angles, which is this angle and this angle, are both 90 degrees. So on to the next circle theorem. This one states that two radii form an isosceles triangle. Now, radii is just plural for radius, so we're going to draw two radii out. Remembering that they start from the center of the circle, touching the circumference, one like that, and another one like this. So we know that radii are all equal length no matter where you are on the circle. And if we connect those points at which they touch the circle with a chord like this, that forms a triangle. And thanks to this theorem, we know that this is an isosceles triangle, meaning that both of the base angles are equal. And just so the circle theorem sticks in your head, let me draw another radius like this. And remember, they're all the same length. And then connect this radius with another radius with a chord like this again. And again, these form another isosceles triangle, but with different angles than the other isosceles triangle. So let's move on to the third circle theorem now. The third circle theorem states that the perpendicular bisector of a chord passes through the center of a circle. This might sound confusing, but I'm going to break it down by drawing the chord first. So let's draw that like this. Now this word perpendicular just means 90 degrees. And this word bisector means the middle or half. So let's start by drawing a line that's perpendicular to the chord. So a line like this, and at 90 degrees, it's roughly like that. So this angle would be 90 degrees, but this doesn't split the chord in half. Therefore, we're going to move it so that it looks like it bisects the chord, and it looks like it's right there. And the circle theorem says that this line should pass through the center, which it does. This circle theorem doesn't usually come up on exams, but it's still good to have in your arsenal, even though they don't score goals. So moving on. So this circle theorem says that the angle at the center of a circle is twice the angle at the circumference, provided both angles are subtended from the endpoints of the same chord. Let's start off by drawing a chord. So we're going to put our chord right here. So let's draw the angle that's made at the center. So we're going to connect both endpoints to the center of the circle like this. Then we're going to make the angle at the circumference, making sure we draw it from the same chord. So starting with this endpoint, I'm going to connect it to the circumference. Then I'm going to connect the other endpoint to the exact same place, and this makes an angle. We'll call it theta. Now the circle theorem is basically saying that the angle at the center is going to be twice this angle. So if this is theta, this angle right here is going to be 2 times theta. We've got 5 circle theorems left. Let's keep going. So this circle theorem says that the angle in a semicircle is always 90 degrees. Now remember from the beginning of the video we said that a diameter splits a circle into two semicircles, like this. And what this theorem is saying is that if we use the endpoints of this diameter, so using this endpoint and connecting it to the circumference, then this other endpoint joining the exact same place, then the angle that's made right there is always going to be 90 degrees. And it doesn't matter where we made the angle, so if we made an angle right there, that'd still be 90 degrees. And even if we made it on the other side, that would still be 90 degrees. There's nothing left to say about this, so let's move on. Angles in the same segment are equal. Before we do anything, let's just split the circle into two segments, so the minor segment and the major segment. Then looking back at this, it says the angles subtended from the endpoints of the same chord onto the same segment are always equal. All that is saying is if we made an angle like this, so connecting these 2 points on the same part of the circumference, this angle right here, we'll call it theta, should be equal to any other angle made in this segment, provided it comes from the same endpoints of this chord. So let's draw another chord here, connecting it to that part of the circumference to make another angle. This angle should also be theta. And if we made another angle there, it'd also be theta. If we made another one there, it'd also be theta. How about the second box? It says the angle subtended from the endpoints of the same chord onto the opposite segment add up to 180 degrees. Now all that means is that if we made another angle in the opposite segment, so let's say this angle right here, we'll call this x. If we take x and add it to theta, so x plus theta, we should get 180 degrees. So x plus this theta is 180 and this x plus this theta is 180. It doesn't matter which way you use them. So let's move on to the seventh circle theorem. The opposite angles in a cyclic quadrilateral add up to 180 degrees. Before we even do anything, we need to define a cyclic quadrilateral. Cyclic just means that the shape is inside a circle, and quadrilateral means it's a four-sided shape. And we should note that all four vertices of the four-sided shape should be touching the circumference of the circle. So let's draw 4 dots randomly around the circle, just so we have our reference points. Then we'll connect them all using chords. So let's connect the first two like this, and then going downwards to this one, going left to the next one, and finally completing our shape going up like this. Now let's label all of these angles. So we're going to call this one A, this one B, this one C, and this one D. And the theorem is dealing with opposite angles. So the opposite angle to A is C, and the opposite angle to D is B. And we're told if we add them together, we should get 180 degrees. So if I take A and add it to C, I should get 180 degrees. And in the same way, if I take B and add D, I'll also get 180 degrees. And that's all I have to say about this theorem, so let's move on. Tangents from the same point are the same length. Well, let's first make a point outside of the circle. So if I made a big point that's blue right here, and then I drew 2 tangents to the circle, so let's say one right here, just touching the circle like that. And then I drew another tangent to the circle, so I'll have to do it right down here because there's no other place to put it. And the theorem is telling us that the length from this point to the circumference is going to be equal for both tangents. And now we have to deal with this part where it says the 2 triangles are congruent. Well, where are the 2 triangles? To create the triangles, I just want to join the radius to the tangent, like this. And I also want to do it to the bottom tangent as well. And remember from a circle theorem, these meet at 90 degrees. So it looks like we almost have a right angle triangle, we just need a hypotenuse. And we get the hypotenuse for both triangles by connecting the point to the center. So now we have 2 triangles that share the radius, so that's one length, and then this length and this length we're told is equal, and then we also have a same angle which is 90 degrees, and that's enough to show that this triangle and this triangle are both congruent. And that's everything to do with the 8th circle theorem. Let's move on to the final 9th one. This is the hardest circle theorem, and it has a name to it. It's the alternate segment theorem. So the angle between a tangent and a chord is always equal to the angle subtended from the endpoints of that chord in the opposite segment. So that's a lot of words, but let's try breaking it down. Let's start off by drawing a tangent and a chord that meet at the circumference. So I want my chord right here, and if I'm going to make a tangent that meets that chord, I'm going to have to draw it like this. So we've got our chord and we've got a tangent. And the theorem says the angle between them both, so this angle right here, let's label that theta. It's saying this angle should be equal to the angle subtended from the endpoints of that chord in the opposite segment. So this angle is in this segment right here, and this is the segment that's opposite to it. And if we're going to make an angle with this chord in the opposite segment, it's going to have to be in this part right here. Looking at the first endpoint, I'm going to join it to the circumference on the opposite segment. Then I want to join it with the other endpoint like this. And this creates an angle that the alternate segment theorem states that it should be equal to theta as well. So this angle and this angle should be equal. And you can look at it from the opposite way. So this is a chord as well, which meets the same tangent. And we have an angle between both of them. We'll call it x. And now the minor segment is here and the major segment is here. So the segment opposite to this is right here. And the angle made from the chord in the opposite segment is therefore going to be this angle right here. So this angle should also be x. And that concludes the alternate segment theorem. This is the hardest theorem and it comes up the most as well. So it's definitely worth learning and memorizing. And that brings us to the end of this video. Hopefully you learned the topic well, but maths is learned through practice. So we've made 3 separate videos for you, going through easy circle geometry exam questions, medium ones, and harder ones, which will all be linked at the end of this video.